Broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, and welcome back to the Green Chemistry Educational Webinar Series hosted by the Green Chemistry Commitment. Thank you for joining us and our speakers today for the Green Chemistry University Curriculum Webinar. My name is Natalie O'Neill. And I'm the Higher Education Program Manager at Beyond Benign, a nonprofit organization dedicated to green chemistry education in K-12 through higher ed. This webinar series is designed to highlight relevant topics in green chemistry education for faculty and students who are looking to adopt green chemistry into their courses and programs. Today's webinar is co-hosted with the Center of Green Chemistry and Green Engineering at Yale, which is committed to advancing science, catalyzing, implementation, and preparing the next generation, all while raising awareness. We are broadcasting live and recording this session. Therefore, all attendees are in listen-only mode and all lines are muted. If you have a question, please type it into the question/chat box on your control panel for one of our monitors, either Kimberly Chapman, the Administrative Assistant for the Center of Green Chemistry and Green Engineering at Yale, or myself will be monitoring the chat box. We will respond to as many questions as we can after the presentation. The recording will be posted on the link you see in the welcome box and on this PowerPoint slide. Any supporting documents, such as the PowerPoint presentation slides, will be posted at this link as well. For those of you who participate in social media, please connect with us on Twitter or Facebook. We would love to hear some live tweeting going on during our webinar, so join in if you like. If you're using this as part of a class, departmental meeting, or event, let us know in the chat box or on social media so we can acknowledge your group and attendance. Thank you for joining us for this webinar and taking part in the discussion. This webinar is being brought to you as part of the Green Chemistry Commitment Program, which is a consortium program aimed at transforming chemistry education, expanding the community of green chemistry practitioners, growing departmental resources for those looking to adopt green chemistry, and improving connections to industry and effectively changing a systematic change in the chemistry education. The program is voluntary, flexible for adopting green chemistry student learning objectives and for promoting the work that you are currently doing at your institution to serve as a model for other institutions to get involved with green chemistry. You can find more information in the link provided on this slide, or you can email me directly at natalie_o'neill@beyondbenign.org. As always, as a part of our webinar, we'll be doing a green chemistry swag giveaway. We will be randomly selecting a winner from the webinar attendance list. We will announce the winner at the end of the presentation and contact you after the webinar concludes to send you one of the following of your choosing that's on the slide. So either a green chemistry t-shirt from Beyond Benign, a real world case study, textbook in green chemistry, or green chemistry theory and practice by Paul Anastas and John Warder. We are happy to have a wonderful webinar for you today on the Green Chemistry University curriculum. So now to introduce our speakers. First, our very own Dr. Amy Cannon. Amy holds the world's first PhD in green chemistry from the University of Massachusetts, Boston, where her research involved the environmentally benign synthesis of photoactive materials. She is a co-founder and executive director of Beyond Benign. Amy is passionate about transforming the general public's relationship with chemistry. She focuses on chemistry education to better prepare students and scientists to enter the workforce trained with the skills to create sustainable materials and products. Through Beyond Benign, she leads an educational initiative to bring together multiple stakeholders around this common goal. We have Dr. Carolina Malero, Malero, joining us from the program manager of the Center of Green Chemistry and Engineering, bringing 9 years of biotech and academic background and professional experience to her position at Yale. At the center, Carolina manages research and education products and actively promotes the center's activities by leading educational efforts and translating research into teaching tools to educate diverse audiences in green chemistry and sustainability. Dr. Meller is an expert in online and traditional teaching and educational design and workshop development. So with our introductions complete, I'll turn the controls over to you, Carolina, and feel free to take it away.
Thank you so much, Natalie and Amy. It's a pleasure to be with you here today. All right. So the European Chemical Industry Council study shows that the global market has exceeded over 3.5 trillion euros just in 2018. And while it is not surprising that the world chemical sales are increasing globally, what is surprising that the majority of growth from 13 to 28% happens in Brazil, Russia, India, Indonesia, China, and South Africa. At the same time, while the chemical sales are tripling in these countries, the OECD share in world chemicals is decreasing. This study is also supplemented by the recent forecast by American Chemical Council that predicts that there will be significant growth in chemical production in developing countries as well. So given that data, we need to be starting to think about innovative approaches that help to reduce the use of hazardous chemicals, especially in non-OECD countries, and not only at the end of their lives, but throughout their entire industrial life cycle. We need to be thinking about the holistic approach and wide-ranging action that leads to benign by design and ultimately to the goal of zero waste. In other words, can we use green chemistry and green engineering approaches to simply leapfrog countries to sustainability? Can we use green chemistry and green engineering to build resilient infrastructure that promotes sustainable industrialization and that fosters innovation? So together with Global Environment Facility, United Nations Industrial Development Organization, and the Center for Green Chemistry and Green Engineering at Yale, formed the Global Green Chemistry Initiative. The Global Green Chemistry Initiative's mission is to raise the global awareness and capacity around green chemistry and green engineering, specifically around products and processes that advance environmental benefits. The initiative is made of many groups and individuals. There is Center for Green Chemistry and Green Engineering at Yale. There is United Nations Industrial Development Organizations, Global Environment Facility, but also we tapped into many green chemistry experts in academic research, as well as green chemistry experts in education and communication, namely Beyond Benign and Experts Clearly. In addition to all of these groups, we also work with national cleaner production centers. National cleaner production centers have been around since mid-90s and have been established by UNIDO with the sole goal to help businesses and governments. As of today, the network is present in over 70 countries around the world. The NCPCs have multiple roles, but the first and foremost is to the improvement of productive use of natural resources while minimizing impact on nature. As doing so, NCPCs also support communities and help improving the well-being of workers to reduce risk. And so the Global Green Chemistry Initiative partnered with National Cleaner Production Center Network and with Global Green Chemistry partners to develop training materials to develop awareness and capacity around green chemistry, and also to help guide some of the countries to green chemistry and sustainability. And to create the robust ecosystem that will be well sustained after the collaboration is completed, the Global Green Chemistry Initiative decided to target 4 main audiences. And these are governments, industries, NGOs, and academia. In the last 3 years of our work, we reached out to over 750 people in 14 different countries. And this work couldn't have been completed with 11 international green chemistry experts. Many of these experts don't need introductions, but I do want to mention that we worked with McGill University that specializes in mechanochemistry, synthesis, catalysis. We worked with Queen's University and Nottingham University that specialize in solvents. We worked with Green Chemistry Foundation that specializes in upscaling of green chemistry. We worked with the George Washington University, who is a leader in safer chemical design. And finally, we worked with Warner and Babcock Institute, who leads green chemistry innovation, and with Beyond Benign, a leader in green chemistry education. As a result of this initiative, the initiative put together 4 main deliverables. We started with 1-day and 5-day workshops. And these workshops were delivered in 6 countries and helped our local partners to become hubs for education and training in green chemistry. The 1-day workshop was specifically designed to raise awareness around green chemistry to NGOs, industry, and academia, while the 5-day workshop took a much deeper dive in green chemistry and introduced tools and practices and case studies. What's most important is that this workshop empowered facilitators, participants who can then become catalysts of green chemistry within their regions. Our second deliverable was a guidance document. A guidance document is a 30-page document which we like to call a roadmap to green chemistry implementation. The document is written in a very approachable way, and it's for individuals who simply don't know how to get started with implementation of green chemistry in their region. In addition to practical tools, we also included a network that is worth tapping into in terms of research and also education. The third deliverable is the technology compendium. Technology compendium is the robust compilation of commercial green chemistry technologies all around the world that are currently present. The document showcases, well, is there to prove that you can do green chemistry and be a successful business. Both documents, so the guidance document and technology compendium, will be available on our Global Green Chemistry Initiative website by November of 2019. And finally, we developed a university curriculum. A university curriculum simply to educate the new generation of chemists in green chemistry. Okay, So what exactly is Yale-UNIDO University curriculum? Well, it is an introductory course for undergraduates who have not been exposed to green chemistry. It is designed for freshmen and sophomores, but some topics can be also used for juniors and seniors in their advanced classes. The curriculum has been developed in collaboration with Beyond Benign, who is a leader in green chemistry education. And the materials have been released in the summer of 2019 after feedback from our partners, UNIDO, and also green chemistry experts. And while the curriculum has been available only for a couple of months, we already know it has been implemented by many different universities around the world, including 7 South African universities and universities in Colombia. So what is the curriculum like? Well, while there is still an emphasis on green chemistry and sustainability, it is still a chemistry course. There are atoms, molecules, reactions, and nomenclature. In fact, the first 7 lectures include chemistry basics that are needed to appreciate the content afterwards. At the same time, it is an environmental sustainability course, and there is a wide range of environmental and energy issues that are discussed. And later, how green chemistry and its principle can help address these issues. The course is very practical, and it places chemicals in context of our daily lives as well as the society. At the same time, the curriculum is also a very analytic course. There will be tools and protocols and an analysis that students will have to do to better understand science and make science-based judgments about chemicals, materials, and products. After students take this course, they will be able to tell whether product is green and sustainable. But I think more importantly, they will be able to make recommendations how chemicals can be actually made greener and be improved. So who is the curriculum intended for? The curriculum is actually intended for chemistry faculty who is thinking about adding more green chemistry into their current offerings. And this can be achieved by multiple ways. If you don't have green chemistry in your current department and are thinking about including the entire course, you can easily do that. Our course has 27 full lectures with PowerPoints, readings, class exercises, homework assignments, midterms, and of course answer keys. There is a reason we call it course in the box, because it has everything you need in order to deliver a successful course without having prior knowledge about green chemistry. However, if you're less flexible, you can also deliver sections of the course. If you're currently teaching a course, but you want to make a connection to innovation, energy, recycling, biodegradation, the course allows you to do that. And finally, if you're teaching a more traditional course like organic or inorganic chemistry or perhaps general chemistry, and you don't have a lot of flexibility within your current curriculum, you can borrow examples and exercises from Yale-UNIDO University curriculum and include more green chemistry through that. What we try to do is also include a diverse multimedia content. So you will see a number of lab exercises, discussions, videos, and even a green chemistry game. This is all to encourage the teamwork and also hands-on learning. And finally, the course is copyright free, so you can download it easily, add to it, and use it within your school without any additional permissions. Okay, I think with that, I'm going to turn it over to Amy, who will tell you a little about the course itself.
Awesome, great. Thank you so much, Carolina. Thanks so much. It's been great working with you and the team there at the center at Yale on this curriculum. So, and it's nice to be presenting with you. It's nice to be presenting on the presenting side as opposed to the moderating side today for the webinar. So I'm going to walk you through some examples so you can get a taste or get a sense of what's in the course materials. But before I get to some specific examples and walk you through some of those examples, I wanted to put this in your head, how you might think about using the course materials. As Carolina mentioned, it's designed to be, you have all the materials to run a full intro to green chemistry course there, so it includes all the materials that you would need for that, and they're all editable, as Carolina also mentioned, so you could add or remove things as you saw fit. So it could be a standalone course. You can also think about using specific modules within the course. So you could just select one particular module that you had an interest in. You could also select out and pull out just some case studies to introduce into your existing course. Or you could link to and connect it with some of the supplemental resources, which I'll mention, such as some of the supplemental videos, either that are external videos that are open access, open source videos that we've added into our lesson plans, or the videos that are included as part of the Yale YouTube channel. They have some really great resources there. And then finally, I'll tell you a little bit more about what's in the homeworks and exams, and you could also just get some ideas from the different homeworks and exam questions along with the answer keys as well. So you could think about using, I'm sure there are other ways to use the course materials as well, but these are some that we've selected here. Can you guys see my screen okay, Natalie, real quick? My screen seems to be flickering, so hopefully on your end it's not flickering. Okay.
It's all good.
Well, let me know if you do. It's all good? Okay, perfect. Excellent. So I'm going to use my other screen then here. So the topics within, as Carolina mentioned, there's 27 lectures, although you'll notice that, they're numbered. You'll see 1 through 26 here on my list here, and I've kind of tried to group them into categories so you can get a sense of the different kinds of topics that you'll find throughout the course materials. And by the way, you can download individual course materials or you can download the whole thing. So they're all there. But 3 of these out of the 27 lectures are exam placeholders for exam times. So, and I'll talk a little bit about that too. So here's a range of the topics that you'll see, from introduction to green chemistry and understanding the principles of green chemistry to a little bit of the background of sort of the introductory chemistry course materials. Because again, if this is designed for, if you are using this for, say, a non-science majors course, then there are some introductory materials that you could use for introducing chemistry concepts that will allow you to talk a little bit more about the chemistry and you know, get a little bit more in depth in some of the other lectures. So there's those course materials. There's specifics of sustainability and how green chemistry connects into the broader sustainability and life cycle assessment, things like that. And then you'll notice some of the more common topics across the 12 principles of green chemistry, such as renewable feedstocks, designing for degradation, recycling, and some, you know, catalysis, solvents, all of these things. So I'm going to walk you through a few examples of these to give you a sense of, again, what's in the lesson plans and what's in the lectures and what to find in some of the supplemental resources. And they're all structured similarly. So I'm going to start with an introductory lesson. So I picked lecture number 3. And you might not be able to see on your screen the lesson plan contents, you know, the lesson plan here on the left. So I've pulled the contents out on the right to explain a little bit more. But each lesson plan has within it basically a description, so an overview of the lecture contents, This one's a fairly straightforward one because it's about the 12 principles of green chemistry. So there's your lecture contents. So this one, again, pretty straightforward. There's also materials that are in there recommended or required, I should say quote unquote required, because it would be up to you as an instructor whether or not, what readings you might require and what might be supplemental. But there's, these things are listed in the lesson plan. There's also direct links, hyperlinks over to videos, and as I mentioned, they could be external videos that are open source that demonstrate a concept within the core, within the lecture, or they might be, again, supplemental videos, such as the Yale videos. They have a great set of resources there. And then we have sort of an outline of the topics to cover in the lecture. Again, this one, our detailed topic list is pretty straightforward since we're talking about the 12 principles of green chemistry, so that is within this lesson plan. And finally, the second, so this is on the second page here, we have suggested class exercises. This one as an intro, and this could be in-class discussions, it could be hands-on activities, it could be lab-based resources. So it's very, I guess, tailorable to whatever course you are teaching and whether or not you want to introduce an activity within your, or if you did not have a lab component, then obviously don't include the lab-based exercises. But they're there, and we link to them whenever possible. So this one has a couple that are actually our resources at Beyond Benign. They're nice introductory level course materials, such as the E-factor activity, which you may have seen, but it demonstrates candy such as M&M, and you can calculate the E-factor and understand a little bit more about the environmental impact factor of a process, getting a little bit into the metrics of green chemistry. And then another course, the second one that we have here in this one, is writing the 12 principles. This is an introductory level one that we have actually written up for our high school level, but it's very applicable and could be scaled up or down depending on your audience level. But basically, students are given a pretty wasteful process for making a product, and they are challenged to rewrite the process, and in doing so, they actually come up with the 12 principles of green chemistry themselves. So it gives them a deeper understanding of, and that sort of hands-on approach of the 12 principles of green chemistry. And I should mention that all of these slides are in your control panel as a handout. So if you're, missing a link or something like that, or you wanted to follow up on this, it's all in those. It's all in the slides that we've shared with you, and they'll also be posted on the recording link as well. So each lesson or each lecture has a lesson plan with all of those materials, and then each lecture has a slide deck for you. So PowerPoint slides, again, they're editable, so they're open. You can use, you can input your own information in here. And some of them have quite a bit of information in them. So this is a good example. This lecture number 3, the 12 principles of green chemistry. Again, fairly straightforward in content, where we go over the 12 principles of green chemistry, and within it provide some case studies and examples of each. So I just pulled out one as an example to show you and give you some ideas about how you might, again, use some of these course materials. So I chose safer solvents to share with you. So we have a definition of this principle of safer solvents and auxiliaries here. Pretty straightforward. We have some background information about safer solvents, things to think about and consider when thinking about safer solvents in a process, and the potential sustainability impacts of solvents as well. We then have, again, more background information about thinking about solvent substitution to greener alternatives, and then we have discussion points and more supporting PowerPoint slides along for each of these to hopefully provide a framework. We then go into some case studies. Again, there's a lot within this one. So what I like about this example is that there's some classic case studies which you may have seen, such as the coffee decaffeination in the comparison of using organic solvents such as dichloromethane versus the supercritical CO2 extraction, and sort of the benefits of that. But then we also have additional case studies such as the use or the application of green chemistry in medical sterilization. Typically ethylene oxide is used, and again, another supercritical CO2 example. We then move on to some additional case studies, and as you're going through and reviewing the course materials in advance of whatever you're using this for example, if you are, I love this example of replacing dichloromethane in chromatography. It's a really great paper that was out of the pharmaceutical sector as part of the Pharma Roundtable here, and it's a great resource. But maybe it's too much for if it's an introductory level course that you're teaching for non-science majors. So this, you can easily remove this slide as a case study. Or if it's a little bit more of a chemistry intensive course, you can use it, maybe expand on it as well. And then we follow up with additional case studies such as the Zoloft Presidential Green Chemistry Challenge award-winning example here from the pharma sector. So again, you can there's a lot within that one just for one of the 12 principles. So you can include them all or remove them as you see fit and as you're, tailor it to your audience. So that's the kind of nice thing about them. You can pick and choose as you like, or supplement and add to it. So that was my first example on the introductory. I'm going to share a little bit about the intro and a little bit of background on chemistry, because again, as Carolina mentioned, it's a chemistry course, so we want to be able to provide enough chemistry background for students to have that sort of deeper discussion. So we have some intro level course materials in those lectures 4 through 7. Again, you'll see the lesson plan is a similar structure with the description, overview of lecture contents prior to lecture. This one I'm going to pull out a little bit more of the topics that we cover in this lecture, because you'll see, again, they're introductory level concepts, right? So molecular weight, Avogadro's number, molar mass, getting to think about balancing equations, stoichiometry, again, basic concepts. But then we're building on this and actually linking it to, as we're building this, we're learning more about some of the basic reactions, and then we're relating it to green chemistry, and we also make links to biomimicry as well, and how nature performs some chemistry and nature versus lab. So we have some information in there. And then we're always trying to bring in that green chemistry perspective as well, of course. So this lecture has quite a bit of course materials within it. And then finally, the optional class exercises. Again, this is an introductory level, so we have some course materials that we have included as supplemental or optional class exercises, including a reactions lab if you have an opportunity for a lab-based activity. There's a simple biomimicry matching game, which could be tailored to many different levels, and a stoichiometry challenge that we've linked to that's from our own curriculum database on our website, beyondbenign.org. The biomimicry matching game one is kind of fun, and it seeds some ideas for thinking about how we might generate some ideas for greener chemistry. So this one specifically, I just drew up a couple examples here where we have, it's a simple, students are given out cards. One set of cards has sort of the organism or the phenomenon in nature, and then the other set of cards is the greener technology or the product that was inspired by that organism. And they're supposed to make these matches. This is on our intro one. We have an intro and an advanced one. So there's simple connections such as, you'd make this connection here with the Morphos butterfly, and this fabric out of a company in Japan that is actually not a pigment in that fabric, but it's structural color inspired by the Morphos butterfly, which also does not contain pigment, but it's structural color. And to maybe one in the green chemistry community that might be more familiar, which is the blue mussel inspiring the development of a formaldehyde-free wood adhesive that was in one of the early Presidential Green Chemistry Challenge Award winners. And so there's a whole set of cards that can be used, again, to sort of seed some of these discussions, and could be a nice place to start within a course. And then finally on this, we have supplemental materials, and this one includes additional lab-based activities, such as a nice link to the American Chemical Society vitamin C clock reaction, things like that that might help supplement and enhance some of the concepts that you'd be teaching. So within this one lecture, here's the examples of the PowerPoint slides. Again, pretty basic. I'm not going to spend a ton of time on this, but we provide the overview slides. We have an outline of the contents of the slides here, and again, some samples. I figured I had to keep this one in here for Mole Day today. So some of the basic chemistry here that you might be introducing to students. To building on that, to writing and balancing equations, stoichiometry. Again, you're building sort of a little bit of the chemistry background and knowledge, to getting it a little bit more into types of reactions. And these are not in the exact order of these are just pulled out a selection from the PowerPoint slides. There's no way I could show you all of everything that's in there. So it's sort of a selection from this lecture. Again, we have a discussion around the nature versus lab ideas, and you know, how nature does chemistry, and sort of getting ideas from nature, and how we might typically approach chemistry in the lab. So there's some nice discussion points, I should say, for lectures in that. And then we, of course, are connecting it to green chemistry and how we might approach designing an ideal green chemistry reaction. And all these concepts are elaborated on in the following lectures. So this sort of sets the stage for that. And then again, I mentioned there's connections to biomimicry within this slide deck, and sort of defines that, and have some really nice quotes and images from the Biomimicry Institute and some partners in biomimicry as well. Okay, so going through this pretty quickly, I've got a couple more examples to share. I figured I would pull out Catalysis, with being Marvelous Metals Week this week at National Chemistry Week. So again, I'm not gonna go through again. The lesson plan contents are essentially the same. They're all there. This one includes an outline, so catalysis, and again, more of a discussion on sort of the ideal greener catalyst. This one includes a really nice video from the Yale-UNIDO. Again, this is a really nice one that we include. We couldn't embed it in our PowerPoint slide because it would just make it too big for the download, but you are welcome to do so in your own way. We give you the link right there. This one also includes some learning objectives for students, and again, it's sort of that talking about catalysis and the role in green chemistry. You'd see, some sort of more traditional things such as reaction coordinate diagrams, and then sort of this discussion of the different types of catalysts, and sort of that sweet spot of a greener catalyst. What are the things that you're looking for in a greener catalyst that you would ideally want to have? Of course, as Marvelous Metals Week, we have to also include a slide on the ACS, GCI, and compound interest. It's a great infographic here if you haven't seen it yet. I'm sure it's been posted in social media today too, or this week, I should say. But the periodic table endangered elements, so should also be, again, part of the discussion in catalysis, where we rely on metals heavily in catalysis. So there's a nice discussion here on the abundance of various metals and their use. So that was a brief overview of catalysis, and again, I can't walk through each example, but there's more and more to dig into here. Another great example that I really like that could be a standalone one is the Green Analytical Chemistry lecture. This is a nice sort of supplemental one, particularly for an analytical course. So again, the course materials are going to look pretty similar with our slides and our outline. But basically the contents of what we have in this one, you basically go from sample prep to instrumental analysis and how green chemistry applies across this field or across the spectrum to real-time analysis and process analytical technology. So there's a lot of information in this one and a lot of things to consider. This lecture is based, this is one of the primary sources or resources that we used in this lecture, although we used others as well. But this is a really great chapter, book chapter by Paul Ferguson and Doug Rainey at South Dakota State on green analytical chemistry. So some great resources which are also included in the lesson plan materials to dig deeper into this. Okay, so those are some things to use. And finally, my last example here is we have one lecture that just is on real-world case studies. So you could pull out just one case study that you wanted to introduce to supplement your course materials. So again, within this one, here's our outline. We highlight 7 different Presidential Green Chemistry Challenge Award winners over 20 years of the award since it started in 1996. So you'll see there's a selection throughout. We tried to space it out over time to kind of, give some different examples from the span of the award. It's a really great resource for case studies. So for example, if you said, okay, I'm teaching solvents, we're looking at, either alternatives to organic solvents or means for, performing chemistry in an aqueous system. And I really like this Bruce Lipschitz example. And by the way, there was a great webinar that the ACS held where Bruce, gave his talk a couple weeks ago, or maybe it was last week. But so you could just select that one, and you'll see that we've got, you could just pull out those slides. Professor Lipschitz was very nice to share these slides with us and to share there's additional information and background reading with the primary literature that you could dig in deeper to some of these concepts. So there's some great chemistry here with some of his surfactants that allow for chemistry to be performed in water. So you'll see some of these slides and all the different applications of these surfactants, performing some of these chemistries right in room temperature and water. And then there's also some further background information or I guess graphics here on what is a micelle. So that might be, something to introduce at more of the introductory materials too. Okay, so I think I've gotten through my examples. Yes, I've gotten through my examples, and finally I'm just going to spend like a couple minutes on what else we have. So we have 6 homeworks that are supplemental to the course materials. Lectures 8 and 18 you'll see are not there, and those are placeholders for in-class exams. And we have a good number of exam questions with the answer keys that are available that you could select from. And finally, we have a final exam. So what's in those? The homeworks that we have range from introductory, sort of to help supplement some of the introductory lectures, to things like estimating biodegradation, to a great solvent selection guide activity that uses Chem 21, which is a great resource if you haven't looked at it already. This is a great resource out at York University in the UK. It's a great solvent substitution tool out there. And then finally, we have the last 2 that are a little bit more related to the toxicology, sort of those later lectures. And again, all of them include answer keys. The exams, we have 41 questions with answer key for the first, 54 questions, and you'll see this sort of disclaimer or note to the instructor on each of the exams, and it says, basically, here's a list of questions, pick which ones you want, and maybe supplement, add others as you, and it's just a guide. So, but it might help seed some ideas too if you're newer to the field as well. So, and finally, the final exam has 95 questions there. So there's a good number of materials there to dig into. And that concludes my part of the presentation here. Again, hopefully that's given you some good ideas about how you might use the course materials. we would love to hear how you're using the course materials and hear from you. So please do share that with us as you're digging into these things. Okay, so with that, I think I'll hand it back over to you, Natalie and Kimberly.
Great, thank you, Amy and Carolina. It was an awesome presentation about all the curriculum has to offer. I know you can't cover it all in this short amount of time, but hopefully you've given people a taste of it. There's been some great questions coming in through the chat box, and Kimberly has been great at answering them. So one that has actually come up twice, so I think it's a point to mention it to everyone. How long are these lectures planned to take? Is it a 1 hour or an hour and a half class that they're intended for?
Sorry, I was on mute. Yes, they should be. They are about an hour in length, I would say, on average. I think that's what we aimed for. So, but you certainly could select out some of the slides if you had a shorter amount of time.
I agree. Some are more 75 minutes, but overall, we aimed for a traditional lecture length.
Great. So another question that came in is, do you have any means right now to collect feedback from users? Is there a survey, a student opinion? How can they give you their feedback? How would you like that feedback sent back?
Great question. Got it.
So we might try to tackle this one. We developed a survey there is one survey that's intended for students and one survey intended for teachers that go along with the curriculum. And we haven't posted it yet just because the curriculum has been just recently released, but we're very happy to share that and collect feedback as it comes in.
Great. So there is a question coming in about, do you have materials for a practical course? And I think that means a practical course meaning an experimental course. So Amy, do you want to touch on that?
We don't. I would say there's not necessarily in this course materials. You might be able to pull out some of the things that would certainly have the practical applications. So that one, you know, and maybe we could go through and suggest some things that might be more relevant to a practical course or that sort of scenario. There's some really great other examples of practical courses that are out there that are lab-based, such as, you know, that we could also connect you with too, that are beyond these course materials, but that could be nice models. I'm thinking of the one at University of Toronto that's a nice advanced synthetic course that was published in JChemEd that might be a nice model to look at. So I'd be happy to follow up with that if that answers the question on the practical side.
Sure. We have one more question. Is there a movement from chemical sales companies to promote green chemistry in their sales, particularly in the high school level? So this is something that came earlier into the chat box, and Kimberly responded, not that we're aware of, but Amy, I just want to direct that kind of to you. Do you know if there's any movement from chemical sales companies to promote it towards the higher high school level?
Yeah, we've had a partnership with Flynn Scientific, which is one of the biggest suppliers to high school chemistry. And so we have 4 kits that are available, green chemistry kits that are linked to our curriculum, but you also don't need to buy the kits, but they're just nice convenience thing too, because we provide, you know, the list of materials that you would need. But so Flynn, and we're working with them to provide, I think, an additional 4. But Flynn is a nice, again, we have a good working relationship with them. They are interested in seeing this as a growing area, so for sure. On the academic side, I would say Millipore Sigma's done a pretty good job of that. They have some great resources on their site for greener alternatives, and they have a great new tool that we just hosted a webinar on too for analyzing chemistry according to the 12 principles called Dozen. So I think there's movement in both the kind of the research, higher ed, industry side, and also the high school side. So I think it's encouraging that we have, you know, Flynn Scientific and Millipore Sigma, which are two of the biggest chemical sales to the education community and research that are taking some steps in that direction. So, yeah. And I can send out more information on that too if there's interest in following up on that.
Great. There is one more question here. It says economics of green chemistry alternative products. So I'm going to say that that's a question around whether that's included in the curriculum.
Yeah. I'm not sure if we included the economics of the green chemistry alternative products. Would you say that, Amy?
Right. I'm wondering, there might be some of that in like the life cycle, because there's definitely economic considerations in that. And then we do, I mean, it's part of the green chemistry discussion is the economics. There's also some other case studies that are beyond this curriculum too that sort of point to the economic value of that. And we have a little bit of that too in our green chemistry resource guide for the organic lab course, sort of the economic benefit of shifting towards, say, a greener organic lab versus a traditional one. So there's some of it there. Trying to remember if there's any other specifics within I would certainly say in the Presidential Green Chemistry Challenge Award slide deck, those some of those also do have some economic analysis within them, or at least making the case that it is more economical for it.
Great. So if you have any follow-up questions for Amy or Carolina, please feel free to put them into the chat box now. I'm just going to announce our winner of the green chemistry swag as we wait for those final questions to come in, if there are any. Our winner today is Melissa Calabria. We'll be contacting you after the webinar to ask you your choice of the green chemistry swag and send that directly out to you. So congratulations, Melissa. Thank you for joining us today. So I don't see any last questions coming into the chat box. Of course, you can contact us at Beyond Benign or at the Center of Green Chemistry and Green Engineering at Yale. Thank you for a wonderful presentation, Amy and Carolina, and for giving us your insight of how this free Green Chemistry University curriculum can be used by the community. Thank you for listening to our webinar. Recordings and supporting documents will be posted on the website listed on this slide. Sign up for our mailing list on our homepage at beyondbenign.org. You can also sign up for the Center at Yale's monthly newsletter. That information is also here on the slide. And we hope that you will come back and join us on November 20th for our next webinar, which is going to be with the ACS GCI Pharmaceutical Roundtable on some of their tools that they have for inventing chemistry in a greener process. So with that, I'll say thank you for your time and for joining us today.
Thank you.
Thank you.